to Broadband Breakfast Live Online for Wednesday, June 28th, 2023. I'm Drew Clark, editor and publisher of Broadband Breakfast. Really excited to welcome all of you to this Broadband Breakfast Live Online session. One of the things that we do for, now it's going on 3.5 years that we've been doing Broadband Breakfast Live Online. We bring together the community focused on broadband infrastructure, broadband's impact, and big tech and the regulation of big tech. We've covered so many topics. It's astounding, and we obviously other people, some of our hosts, even some of our guests on the show have other programs. We watch them. I'm sure they watch ours, and it's great to share in that knowledge of our broadband community. We at Broadband Breakfast are just coming off an all-day event yesterday. It was the Made in America Summit in Washington, D.C. It was at Samsung Executive Center. Really exciting. We have reports of those, news stories of those that will be available on our site. And we will, for Breakfast Club members, have videos of the presentations in a few days, coming soon. Right now, I want to turn to the discussion we're having. It's been a very busy time for the broadband world. On Monday, of course, President Biden announced the allocations for each state in the BEAD program. BEAD, of course, is the Broadband Equity, Access, and Deployment program of the Infrastructure Investment and Jobs Act. These awards announced Monday kind of give some concreteness, if you will, to the BEAD program and to the bipartisan infrastructure law. So in some ways, it's kind of the starting gun for a lot of short-term activities on the broadband front. But today in our Broadband Breakfast Live Online session, we're going to maybe step into the future a little bit, or examine some aspects of the future as we talk about ultra high speed connectivity, the technologies that are being used, technologies that might still be used or could supplement existing technologies. And as we all know, the BEAD program has had a very strong focus on fiber deployments. And so that kind of in some ways is the, theirs to lose type of thing, right? So we're gonna hear from guests in various technologies, who work in various technologies, for what we hope will be a very lively discussion and lively debate about high capacity, or really ultra high capacity broadband. We'll let the panelists explore what that means. Before I open it up to them, I just want to give a shout out to the sponsors of the Broadband Breakfast Club. We would not be able to do our programming every Wednesday for free without the support of Utopia Fiber, Broadband.money, Comcast, Nokia, the Comlaw Group, Google Fiber, Broadband Now, Michael Baker International, Bitstream Communications, Positron Access, and the California Emerging Technology Fund. Thank you to our sponsors for their support. All right, let's go ahead and open our view to our panelists, and I'm going to introduce each of them. We are joined today by Gary Bolton. Gary, been with us before. Thank you for coming back, Gary. You always make some comment on my beard, so it's great to hear how it's playing in the Alabama wilderness. Gary Bolton, of course, is the CEO of Fiber Broadband Association. And Gary, I just have to congratulate you on the success that you've brought the Fiber Broadband Association over the 2 or more years. I can't remember the exact timing that you've been CEO. I think that the profile's been expanded, and you definitely have brought a real focus on the importance of fiber. Just a bit more about Gary. In addition to running the Fiber Broadband Association, he has worked for 11 years at Adtran, serving as Vice President of Global Marketing and Government Affairs. And he has a really deep and impressive entrepreneurial background, a don't have all the particulars here, but if you ever get some time with Gary, I'd get him to regale you of some of those history and experiences there. Gary, welcome. Thank you for being back. We're going to next hear from Jason Livingood. Jason is Vice President of Technology, Policy, Products, and Standards at Comcast. And in this role, he coordinates Comcast's efforts to develop open standards, spur research and development by leading the Comcast Innovation Fund. We'll look forward to hearing more about that, Jason, and engaging with universities around the world on tactics for expanding broadband capability. So Jason, welcome. We're excited to hear your perspective and learn more about the work that you're doing in this field. Dan Grossman, thank you again. Another first-time panelist on the Broadband Breakfast live online. He brings a wealth of expertise in fixed networks as an industry analyst and technologist. He's an engineer by background and mindset, and he works at the interplay of use cases, technology, and strategy. And his company, Tech Insights, focuses on research and client services in fixed services and equipment, including fiber, fixed wireless, optical networks from service provider and vendor standards. So welcome and thank you for being with us. Let's go ahead and turn it over to Gary to kick us off.
Well, thanks, Drew. And, it's always a pleasure to be on Broadband Breakfast. As you know, I'm one of your biggest fans, and I always love when we can get together. And, you're very handsome with that beard, so I won't make any other comments on your beard. But, hey, as you mentioned, to start with, this has been an historic week for the future of our nation. As, on Monday, President Biden announced the allocation of the $42.45 billion in NTI BEAD funding for critical broadband infrastructure. And I want to emphasize infrastructure that's going to enable all Americans to be connected by 2030. And we're fortunate the administration, Commerce, NTIA, and the states are prioritizing fiber projects for this funding, as fiber is the critical infrastructure. It's going to close the digital equity gap and raise the quality of life for generations to come. There's a number of technologies that can potentially meet the minimum speeds that Congress defined in the bipartisan infrastructure law of 100 megabits downstream, 20 megabits upstream. But this is not about, we saw the failed programs at the FCC of trying to shoot at minimum speeds. This is really about enabling the future of innovation and providing the critical infrastructure for 5G and for future wireless solutions, providing the critical infrastructure for things like smart grid modernization, providing the critical infrastructure of public safety. Today, the average American's getting, 300 megabits or more, and over 88% of the ISPs across the country are delivering a gigabit service or faster for under $100 a month, which is absolutely amazing. So there's no way we want to leave any American behind and not be able to have, provide them the opportunities of the future. Today, as we deploy fiber, the average fiber to home deployment is 10 gigs symmetric. It's using a technology called XGS-PON, that's 10 gig upstream, 10 gig downstream. And we're starting now to see 25 gig PON get deployed. And so as we're seeing commercial deployments of 25 gig PON, and then last year at our conference, Nokia, one of your sponsors, did a live demo of 100 gig PON, and we'll soon start seeing terabit networks and beyond. So when fiber leads, the future follows.
Well, thank you, Gary. A great summary. And Jason, the floor is yours.
Sure. Thanks very much. Thanks for having me today. And I'll just talk and touch on a few things that I think are interesting. First, for folks that aren't familiar with our network at Comcast, we're in the process of rolling out what we're calling our 10G network. And it's a very flexible last mile network. And so up until the last mile, which is really fairly deep into neighborhoods. There is fiber technology, and from there, it transitions from fiber either to coax to the home, so HFC DOCSIS, or to PON to the home. And so, for example, all of our new greenfield builds and ones under the BEAD program are going to be EPON. That's 10G EPON. Similar to other PON technologies, and that'll be interoperable with 25, 50, and ultimately 100 gig PON as well. And then in terms of the DOCSIS, that's going to be symmetric multi-gig services, probably still a little bit higher downstream with the 1 gig upstream, but that's happening as well. And we'll have that available to tens of millions of homes long before we could build fiber to the home to all those passings, which is a good thing. So our network in the future is, a distributed, sort of more virtualized network that can flex to either, 10G EPON over the next couple of years, eventually higher, or, full duplex DOCSIS. But I will also echo, the amazing excitement around the BEAD program and the transformation that that's going to represent. Simply being able to go at all of these marketplaces with, service to that end user, where it wouldn't have been economic before, I think is transformative. So we'll see. And we've applied for or are applying for BEAD funding in many of the states that we're in, and those are all going to be PON based. Clearly, since it's greenfield. I also think, two other thoughts. I think we're also, as you think about fast forward a few years, we have all these people that have gotten BEAD funding. They've gotten, fiber to the home. They've got, full duplex DOCSIS, and they've got, multi-gig to the home and whatever technology. I think then we're in this sort of post-gigabit era, as I like to call it, where other attributes other than capacity really matter. And I think it's still debatable, once you have, let's say, 1 gig symmetric to the home, does going to 2.5 or 5 make a huge difference? Probably less of a difference than it did when you went from 50 megs to 100 megs. And so I think there are all these other network attributes that start to emerge, including reliability, in-home Wi-Fi, resiliency and performance, security services. But the big one, I think, is latency. And I see one of my good colleagues, Dave Tatt, is on here, and that's incredibly important. And it's not just idle latency, but it's this working latency when your network is being used normally. And today in the internet, people have hundreds of milliseconds or more of delay when they're actually trying to do things. And so the network communities put a lot of attention and effort into solving that, whether that's active queue management, AQM being built into things to try to slay buffer bloat once and for all, as well as the new dual queue network standards that the IETF's working on, which we're starting to field trial right now. Thanks.
Awesome. No, this is great, and we really want to drill into some of these technical details. I'm not a technologist. I play one on TV though, so I'll try to ask as much as I can. But we're going to need to get the expertise. And Dave Tate, thank you for being on this call. Please offer your thoughts. It was great to have you on Ask Me Anything not long ago. All right. Dan, give us your perspective on this topic. Take 5 minutes or slightly more, and tell us a little bit about how you come at this topic. Okay.
This is my favorite topic, and I could take it a lot of different ways. The way I was prepared to take it echoes exactly what Jason was just saying. So I'll go through my notes anyway, focus a little bit more on the technology side. I want to challenge Drew's premise that it's all about speed. That is no longer the case. The industry is on a tipping point of a generational change from gig to 10 gigs. So GPON to XGS for most of us, EPON to 10G EPON for a few of the cable companies. North America, China, and some of the European countries are leading that. India, Caribbean and Latin America, Parts of Europe and Asia Pacific are still on GPON and will be for a while. There is a cost delta between GPON and XGS, obviously. That delta is shrinking with manufacturing volume, but it's still significant. It's not significant, though, in terms of total project cost for a greenfield or an overbuild. And the cost delta is going to continue to shrink as the volume grows. So bottom line is, if prices are near parity, why not build for the long-term future? My thesis is that 10G will be the solution for residential and small business fiber for the foreseeable future. The other media are also on that trajectory or close enough, and maybe we can talk about that a little bit in discussion. The industry's been on this treadmill since 1983. Jacob Nielsen quantified it as 50% growth in headline speed, the speed in the big print in the ad per year. And we have service providers offering 1, 2, 5, 8 gig services on XGS and cable. It's good for competitive one-upsmanship if there's competition in your area. And it's really a nice ARPA booster if you upsell it. But really, who needs it? Who can possibly use it? And I would argue that most people who are taking premium speed packages are wasting their money. So think about bandwidth demand from all the devices in the home and add them up, and they don't come anywhere near a gigabit per second. And yeah, there's exceptions: supersized households, congregate living, sports bars, that radiologist in Chattanooga who downloads multi-gigabit MRIs every 30 seconds. The evidence, though, is that while household internet traffic continues to grow, the annual rate of growth is slowing. So, for example, CommScope has been measuring traffic in a number of their MSO customers for quite a few years. And their measurements had the average traffic grow 12% in 2022 versus 78% in 2012. OpenVault tracks a number of operators worldwide. They also saw 12% in 2022 versus 27% in 2018. And there's some good reasons for this that I'm not going to get into today. What all that means is that this gap between what consumers pay for and what they actually use, and that gap is expanding. And sooner or later, they'll catch on. So the industry needs to get off its speed fixation. Fiber wins on reliability, latency, consistency, symmetry, and brand image. And service providers should be using them for competitive positioning rather than those big print up to 8 gigabits per second. The higher speeds will be needed, though, for wireless backhaul, and in particular, enterprise uses, edge compute, wholesale, and MDUs. And those higher speeds are coming, just not for the mass market. Briefly, as Gary mentioned, 25 gig symmetric PON is available now. It's controversial. It is largely a Nokia initiative, although other vendors are supporting it, outside the normal standards process. Presently, Nokia is the only vendor that is shipping, and I believe the only one that's doing field trials. There have been a few commercial deployments worldwide. I'm told that there will be a lot more before the end of the year. And their point in all this was that 25 gig technology is not a heavy lift over 10 gig technology. It's basically speeding things up. I'm sorry, 10 gig, try again, 50 gig, 25 gig PON will be available next year. Chinese operators are driving it, and the Chinese vendors are leading. The standards were completed a couple of years ago. It took a lot of R&D to go into commercialization. This was a big jump from 10 gig. There have been numerous field trials. Huawei announced their product in March for shipment at the end of this year. And we'll be seeing volumes in late 24 and early 25. 50 gig symmetric PON is a couple of years out, maybe 2028. And beyond that, the researchers and the standards community are having some really interesting debates about what's next. Should it be 100 gig, 200, 400? There are lots of challenges there, and particularly the challenge of how do you make it even remotely affordable? But that's at least until 2030 before we get there. And the broad sense is that we really won't need that until around that time frame. So I think I've run out my time. I'll turn it back to Drew.
Thank you. Let's dive right into what I imagine there will be some differences of opinion. Symmetrical speeds, necessary, not necessary. Gary, Jason, Dan.
Yeah, well, I mean, let me start with, first of all, I love Jason's intro. I think he hit some really important parts on just, for instance, latency. You know, when you think about as we get to gigabit networks and 10 gig networks and beyond, you know, latency becomes a long pole in the tent. And as we start to get more immersive, you know, as we start to get metaverse applications and so forth, you know, we have to get down to sub 3 milliseconds. You know, average networks, you know, somewhere around 20 milliseconds and can be worse depending on the way that network's designed. So I do think that is really important. And I wanted to point out that I actually chaired a group called BTAG, and it's Broadband Internet Technology Advisory Group. And my co-chair was from Comcast, a guy named David Don. And BTAG has a great white paper on working latency, because I think Jason pointed out there's a big difference between idle latency and working latency. So I definitely think, you know, that's, you know, something that people should be digging in and looking to. But then get back to your question, Drew, on, you know, symmetric or non-symmetric. I mean, to me, it's no brainer. You know, if I look at, I mean, I just mentioned metaverse. You know, Facebook, Meta, is putting in $19 billion a year into metaverse applications. And the metaverse only works if you have enough, the same amount of upstream bandwidth as you have downstream. You have to have ultra low latency. And then you have to have something called concurrency, which means that you need to be on the same quality experience, no matter where you're located and how many you know, participants are on the application. And so if we're going to be able to really be able to, you know, exploit these new innovations, we have to be able to not be limited by our network.
Jason.
Yeah, I'd say a couple of things. First, I think for many years, the network industry and network operators used capacity or increasing capacity as a proxy for improving the quality of experience for customers. And for 25 years, that absolutely worked and was valuable. But we're kind of at a point of, to some extent, diminishing returns at these very, very high capacity levels that we're talking about, you know, of, you know, 1 gig, you know, both directions. And I also think that when people say that they want symmetry, what they really mean is they want much higher upstream speeds, like 1 gigabit per second, for example. I don't think somebody would say it's better to have 1 gig symmetric than 2.5 gigs down and 1 gig up, right? Or 5 gigs down and 1 gig up. I think they want more upstream speed. There are applications that are driving greater upstream, you know, usage. That said, I do agree with some earlier comments, you know, in particular from Dan and some of the folks that are in the meeting chat, we're kind of building ahead of where the demand is today. And a great example of that, which I posted in the chat, is at the March IETF meeting, 1,000 engineers connected at the same time on a 10 gig uplink connection. And those 1,000 people used at peak like 850 or so megabits per second and 650 or so upstream. And so that was 1,000 people still not exercising a symmetric 1 gig, or in that case, 10 gig connection.
Doing
so
email.
I think we are building ahead.
They weren't working from home or being able
No.
to do any medical imaging or be able to.
Yeah, exactly. But I do think that there's a big component, and we saw this, when the world moved from dial-up to broadband. Once you put the capacity there and you have sufficient scale of capacity, application developers flock in to take advantage of that. And that will eventually drive, higher usage. It may simply be the fact that there's not enough, users with that kind of speed yet to justify an entirely new class or type of application yet, but that'll eventually happen.
Dan, symmetry.
Well, you asked whether it was necessary or not. I always say there's marketing necessary and there's engineering necessary. And it is absolutely marketing necessary. You got to advertise that if you want to one-up your, frankly, cable competition. From an engineering perspective, we have lots of measurements that show that people use a lot less upstream capacity than downstream capacity. And in my view, that will continue. Gary and Jason were talking about the metaverse. The metaverse bubble is bursting if it hasn't burst already. Meta is laying off a lot of their metaverse people. The metaverse bubble in the stock market has collapsed. Apple introduced their new mixed reality headset to a resounding thud. What we think, and I have colleagues who follow this very closely, is that there will be a future for augmented reality as a consumer product. But augmented reality doesn't take a lot of bandwidth. You'd go crazy if it did. Virtual reality, on the other hand, is more an industrial educational product.
So I'm going to jump in here. So I was very short in my question. One word, basically, symmetry, yes or no, right? But and I'm going to come back to something you said in your first set of remarks, Dan, that maybe in shorthand I have preferenced speed, but clearly it's not the most important thing. In fact, for 15 years since I originally launched Broadband Census, which is the predecessor of Broadband Breakfast, we were talking about collecting speed, price, availability, reliability, competition information. And so we are definitely seeing a lot more discussion of reliability, right? And what is the most reliable? And so, Dan, I want to come back to what you said again on the first. You said something about, quote, fiber wins on reliability, latency, symmetry, marketing, right? Consistency. So let's drill into this a little bit more. What is it that allows, quote, fiber to win in your view, Dan? And I'd love Gary and Jason's reaction to that too.
Well, I prioritized those. And fiber rarely breaks. Obviously, if a drunk hits a phone pole and takes down a cable or something like that, yeah, you're going to lose your broadband service. But service calls are very rare. And the reason for that is that there are no active components in the network. In HFC, you've got a node and possibly some amplifiers. all of which have individual reliability limits. And you have cable that has actually been pretty reliable, but not nearly as much so as fiber. Latency, fiber wins, certainly over coax, just laws of physics things. And it wins over radio, unless the radio is very carefully designed.
Now we've just, I'm sorry to jump in. We've heard the first mention halfway through our program of wireless or radio, and I haven't pushed it yet, but I do want to bring it in here. Why is or isn't wireless kind of even in this discussion, right? I mean, and I just, again, you know, we talk a lot on Broadband Breakfast about the importance of better broadband, better lives. And so better broadband comes through higher capacity. Fiber is the gold standard, but there are many, many times you need wireless, not necessarily or not only on the last mile, but there's a lot of middle mile, middle mile, probably the wrong word. I mean, a lot of backhaul type connections, microwave connections. So again, let's hear from others too, Jason and Gary, about, what role do wireless technologies play in portions of a hybrid network, so to speak?
I mean, we live in an untethered world, right? I got my wireless keyboard and my wireless mouse and my iPhone here, so we all want to be untethered. But 80% of all traffic over the mobile network goes over the fixed network, right? When you got your phone, you see the little Wi-Fi offload there and your phone. I mean, the first rule of wireless is get it out of the air and into the ground at the first available point. And so I think, what any wireless network's trying to do is to be able to minimize that, the distance between the device and getting in the fixed network, to be able to have the capacity to be able to, and, to do things that that 5G has promised, and, future technologies, whether it's 6G or 100G or whatever it is. And so we all want to be able to have the benefits of mobility and being untethered. But, when we're talking about infrastructure and being able to have something that's going to foster innovation and be able to do, so we can argue, Dan's looking to the past to say, oh, well, people don't need all these things. They're not using these things. And when you think about, anytime we look at innovation, these are basically major market discontinuities. These are things that are paradigm shifts and are going to really, you can't even imagine what's going to be able to enable. And so we are just at the very beginning of getting everybody connected to be able to have this amazing network. And so, I'll just kind of stop there, and maybe Jason has some comments, but it's, wireless is absolutely critically important, but it's to get fiber as close to the endpoint as possible, and then be able to not have that, if you look at your wireless network or Wi-Fi network in your home, that's usually your, kind of where you have your issues, right? When you got gigabit connectivity to your house, and if you don't have the latest mesh Wi-Fi network, you're going to be limited on capacity. And we're even seeing in Dubai, things like, they have fiber to the room and fiber to the yacht. And so, hopefully we can have good enough wireless connectivity that we don't have to have, a fiber sticking to every one of our little devices, but we can be able to, get that capacity and be able to get it out of the air and into the ground.
Jason, you want to weigh in on the role of wireless?
Sure. I mean, I think from our perspective as an operator, we often think about that in always this last mile lens, but I would turn it around and think about it from the consumer standpoint. For them, wireless is like magical stuff. They can use Wi-Fi in the home, and like literally everything in the home is connected over Wi-Fi. It's rare that somebody's going to connect to Ethernet to something, right? So I love the fact that you have this great standards-based unlicensed spectrum, which has been used so incredibly, in the economy. And I think, that's a great story, and that's going to continue to grow. Hopefully there's more unlicensed spectrum for that in the future. In terms of mobility, obviously that's great. But in terms of, high bandwidth or high capacity sort of home users. I think that the role that, say, a 5G fixed wireless or Wi-Fi last mile or point-to-point or, say, satellite plays is to try to serve those difficult to connect locations, places that may be off the grid. So, it may be, Dave's sailboat or my friend's RV, or it could be, a cabin up in a state forest where they don't even have electricity and they've got, natural gas or solar or something like that. And, fiber is not going to get to those places, or wired connectivity is not going to get to those places. So especially things like Starlink have been really transformative there. Those technologies also, though, have great sort of middle mile backhaul capability. So you might be able to have a mobile network radio tower that, used instead of, Ethernet or fiber backhaul to the internet, used an uplink from a satellite. So I think there's a place for it, but in the last mile for users, it tends to fit into these places that are difficult to serve or where the user has very unusual requirements.
In an ideal world, Jason, would you agree or disagree that fiber should go to every home?
Well, I think you can say our greenfield builds are fiber, and that strongly suggests that the answer is probably fiber. Our network today is almost entirely fiber. It's really, I'll use my neighborhood as an example. If I walk to the corner of my literal block, that's where my fiber node is. So that's like 150 feet away or something like that. And it's a question of, is that last hop coax or fiber? We've obviously got a lot of coax in the ground or in the air that we can take advantage of. But, newer builds, new developments, new BEAD grant areas, those are fiber locations.
Can I just get some clarity, Jason, on is it EPON? And we try to define our terms here, right? So PON, of course, is a passive optical network. And traditionally, as I understand it, again, I'm not a technologist, I play one on TV. There's been this kind of PON and / active Ethernet debate, and no one's weighed into this. I'd love some thoughts on PON, passive optical networks versus active Ethernet. But now as we start to talk about things like SGS PON and and Dan even raised a whole bunch of new standards that China is pushing forward. But could you just elaborate on EPON, Jason, and what exactly EPON is?
Yeah, I think, I don't think it's worth going into too much of the detail of, different variations of PON. They're PON, the basics are all the same in terms of the passive nature of the optical network, and the fact that you get to sort of a split or aggregation point where you might branch out to 32 homes or 64 homes or 128 or whatever it happens to be. That's really different from an active, sort of a fiber-based Ethernet offering. The economics are so different between these two. I think that's why, when you're doing a lot of developments, especially supporting residential, PON is that answer, and it's proven over time to work and scale, and what the reliability and economics look like.
Gary, do you care to say anything about PON versus active Ethernet?
Yeah, I mean, I'll just add on to what Jason said. I think I agree with him 100%. And that, we still see a lot of point-to-point. So active Ethernet is basically point-to-point fiber. So it really comes to the topology and density. So if you have, say, someone that needs a lot of bandwidth and you don't want to have a shared network, you can give them a point-to-point connection, or that, or it just doesn't make sense because the houses are too far away apart to be able to get advantage of having a PON network where you might do active Ethernet, or a point-to-point connection. Yeah. So it's really a topology and capacity question. So it's really there's not a debate on, the economics are so much better with the right densities for passive optical networks. The other part of this that's exciting is, we really haven't got into sustainability. In Europe, they're doing a great job on sustainability. And we just recently did a global sustainability survey that really found that Europe is head and shoulders above everybody in being good stewards of our environment. And we are just
unpack that a little bit, Gary. What does it mean to be sustainable fiber network or sustainable broadband network?
Well, And when you think about our current networks, anytime you have an active device, anything that's powered, so like in the cable network, we have all kinds of amplifiers and taps and things that are powered. In a a wireless network, you have antennas and radios and things like that. So there's all these powered devices, and obviously that's not good for the carbon footprint. And so when you're in a passive optical network, what that means is there are no active components in the network. And Cable Labs has shown has a great illustration of, as they get more fiber in the cable network, the amount of there's a huge reduction in carbon footprint, and really in your OpEx, because you have less powered devices. And so one of the things our study is showing is that as you deploy fiber to the home, you reduce the carbon footprint by 33%. And when you look at the other benefits, such as being able to work from home and so forth, that's equivalent to taking 11 million cars off the road every year. So actually, fiber deployment is going to have a bigger impact than even electric vehicles.
And to be clear, I mean, I know you want to say everything is fiber, should be fiber, Gary, but I mean, it's a broadband network that's leading to these, right? Or are you distinguishing between the fiber and the cable network there?
The fiber, when you go to PON, it's passive. There's no active devices. So that's where you get the benefit. And there's, also in the production of fiber, there's some other benefits, but the big benefit is not having to have these amplifiers and all these powered devices. And so when you think about network reliability, anything that's powered it's going to reduce your reliability of your network.
Yeah.
And it's going to increase your OpEx and so forth.
Especially in some of the states that have problems, maintaining a reliable power grid and have occasional rolling blackouts.
Yeah.
Yeah.
Dan, what are your thoughts on the PON versus active? You talked probably the most about PON and the different flavors or variants of PON. And again, we don't need to go for deep into this, but just at the high level, these technologies do matter in terms of what kinds of speeds, what kinds of reliability, what kinds of latency we're going to have, and also what is your reaction on the wireless question?
Okay, on PON, Jason and Gary pretty much said everything I would say, except to note that there is a lot of carbon footprint that comes with active Ethernet. You have a physical port that draws power in the central office or the hub, as well as the physical port in the home. And those add up. Those add up to current draw. They add up to heat, which means that they add up to cooling. Other than that, all my points have been made. On the wireless, I had 2 points. First of all, the wireless engineering folks have been doing amazing stuff with, I'm going to simplify this greatly, throwing antennas and signal processing and software at all of the laws of physics limitations that they have to deal with. You can forget everything you thought you knew about the limitations of wireless. That does not mean that it is as unlimited as fiber, just that it's there. And my other point on wireless is, I'm going to digress for a second. T-Mobile, Verizon, now US Cellular have 4.75 million customers between them for fixed wireless. And there's lots of reasons why a customer would switch. One of them is that they're able to undercut on price. What these guys are doing is they are monetizing what is otherwise a stranded asset. And that means that they don't need to be paying off bonds, for example, and they can set their pricing really low. And there is a value segment of customers that will always choose the lowest price.
So let me come back to the key point that we're talking about. Maybe we're dancing around it, and so let's get at it directly. Jason, I hear what you're saying. There's a lot of network that's been built with cable. I don't know. We haven't really talked DOCSIS, right? What is the latest standard of DOCSIS, and how good does that get us? Does it get us, in your view, Jason, to the point where you have really good upstream speed so that people can take advantage of those next level of applications, even if it isn't symmetrical gig up, gig down, right? So like what is the state of these technologies now? And clearly, when you've got a huge footprint that has, good downstream and hopefully getting better upstream, what is the kind of economics, if you will, of deciding to overbuild that with fiber to the home? And what you're saying is it just doesn't make sense to do that everywhere. So, give you a chance to elaborate a little bit more, Jason, on this point.
Yeah, that's one key aspect of the 10G network that we have, where we've got this distributed access network. And in that last mile, it's far less than a mile, last few hundred feet, we can be flexible as to whether that's coaxial cable or fiber. And so for us, we have a very flexible network where we can deploy this stuff very, very rapidly, often without changing the CPE to the customer. So for example, we rolled out, 1.2 gigabit per second downstream to millions and millions of customers that now have it. And across all of our, probably 30 to 50 million passings that we have, in a fairly short period of time, compared to what it would have taken, financially and time-wise to put fiber to those locations. And we're going through a similar thing now. We've got the first step is what we call mid-split. So we're changing the spectrum allocation in the HFC network and adding more upstream. So, I think it's more than a third of our network now. Customers can get hundreds of megabits per second upstream. And that all happened, that was not a lot of work from a upgrading of CMTS standpoint. And then the bigger thing,
just to clarify, the 1.2 gigabit down comes with a what up?
To non-mid-split areas, those folks get 35 megabits per second. And to the mid-split areas, they can generally now get 1 to 200 megabits per second upstream. Okay. So substantial improvement by only really changing the spectrum allocation in the network. But the bigger thing is, the bigger thing is going to full duplex DOCSIS, which we're doing now, and that'll enable for example 1 gigabit per second upstream and multiple gigabits per second downstream. And that does better economically, certainly, than us building a PON connection to the home. But more importantly for us, we can offer that to tens of millions of homes, relatively quickly, compared to building fiber. But like I said, we're flexible. There are going to be scenarios where, in particularly greenfield areas, fiber gets built. And then the next question that, my team is helping us navigate right now is, what's that future change point look like when you're doing a maintenance activity and say a storm rolled through a town and knocked down all of the telephone poles, all the plant is gone, or just one street, a tree fell down. When do you decide to sort of backfill and fix that with fiber optic cable rather than coaxial cable? And that's one of the things that we'll be navigating in the near future.
Oh, it's great to get into that level of detail. I'd love Gary and Dan's reaction to what you just said there, Jason.
I'll let Gary go first.
Yeah. Well, first of all, I think what we've seen is that all the cable companies are quickly moving to fiber. All the smaller ones have already done fiber in the home, and then the 3 large ones have a lot of installed copper plants. So it's certainly an economic advantage to do an DOCSIS upgrade than it is to go ahead and finish the job of fiber in the home. But what we're seeing is that, so in 2020, there was very minimal fiber deployments from cable. But then in 2021, we started to see about 5,000 OLT ports. And if you multiply that out, 128 subs per port. And then last year, it jumped way up to about 30,000 OLT ports deployed. And so it's up exponentially. And as Jason mentioned, every cable company is offering fiber to the home on all greenfields. And then they're also building out fiber to the home in competitive areas. And the reason for that is our studies are showing that when a consumer has a choice between fiber and cable or DSL or any other technology, fiber gains 42 points of market share. So from a competitive perspective, a customer is going to take fiber over any other technology. So what that leaves is the non-competitive areas that you can kind of minimize your CapEx investment by doing these incremental DOCSIS upgrades. And so that's kind of a way to focus on. So what cable is doing a fantastic job is on the state broadband programs. They're winning a lot of projects because they're offering fiber to the home. And, you have these companies that have long histories in as a network operator, and now they're offering fiber to the home. So it's, they're being very, very successful. So, as you drive more fiber out and drive more revenue, then you're going to be able to upgrade your network. So I think in a few short years, we can guess whether it's 5 years or 10 years, all the coax will be out of the network and will be totally fiber. And cable companies will call themselves ISPs, no longer cable companies. But again, this is just a process of the very large companies have a lot of installed base, and it's not easy from a public company to invest a lot of CapEx in upgrading things in areas that aren't competitive yet. I don't know if Jason agrees with all that, but that's kind of our
No, I agree. And I keep, telling various comms teams to stop calling it a cable network and just call these, internet networks or something.
Well, I mean, everybody's ISP now, and it's really, and Jason, in your opening remarks, did a great job of talking about it's really not speed and capacity anymore. It's really about in-home experience. It's about there's so many other things, and that's where the best ISPs are going to be the ones that focus on net promoter scores and being able to wow customers with great, not only customer service, but great in-home experiences, and being able to offer more capabilities and features. I love when I'm out of the country and my phone lets me know when someone's walking to my house because they could text their Wi-Fi signature. And, just being able to control what, who gets to watch what and see what, and be able to have all the things that you can do on a good mesh Wi-Fi system. And just, I won't speak for Jason, but there's just some of the amazing things that good operators are doing to make great in-home experiences.
Yeah, I would just say one other thing really quickly about this, which is there's an aspect of broadband equity here that matters. And one of the things that we like about the network that we have is, when we turn up, I'll use Philadelphia as an example where I live. When we turn up Philadelphia for 1 gig, 1.2 gigs downstream, and or in the future mid-split or full duplex, that happens across the entire city, every place that we've got a connection. It's not like we're building only to the higher income neighborhoods first and sort of, doing a bit of digital redlining. And that's an important aspect of this that sometimes gets overlooked. Certainly the BEAD program goes at that with, focusing on these unserved areas. But I do think that there's still going to be a lot of Americans that are going to be worried about sort of getting left behind from the capacity standpoint. And that's one thing that we like, with our network. We can get, that service out to folks really quickly and economically to everybody.
Dan, we've had this exchange, but let's go back to you to see if you have something to say on this point. And then I've got at least two more questions for all of our panelists.
Sure. About a year or two ago, the two largest cable companies in the US, Comcast and Charter, had dueling press releases saying that they could do an upgrade at, I think, $200 and $300 per home with DOCSIS 4.0. And it's a rolling process. So they don't have to spend all that money once. Their cost for upgrading an average home with fiber is $700 a month. I imagine there was a boardroom decision there. And I will say that from a strictly technical standpoint, cable has a very long runway. I would agree with Gary that the MSOs are going to have to replace it sooner than they think. But for technical reasons, I don't really see a huge need for them to go to fiber just on account of capacity.
We've gotten a number of questions on this issue of costs, PON costs, passive optical network, or fiber costs per household. Do you have these broken down? I mean, do anyone want to weigh in on this point as it bears on? Again, we're talking about BEAD funding, and you've spoken, Jason, about how you're going to be building fiber in those areas. What does it cost to do it there or to backfill it?
There's no single answer to that question. In fact, there's really no average answer to that question. Okay, first of all, those costs are proprietary. I can't see them. But aside from that, they vary quite a bit from region to region. They vary with inflation. And then you add on to that the fact that PON construction projects are very different. It costs a lot less per foot for Jason to take a fiber cable and lash it onto his coax than it would take for somebody to dig a trench through hard rock. And that is the reason why we have this extreme high cost threshold in BEAD.
Hey, Drew, I put a great study in the chat. It's
the fixed wireless study.
Well, what it was basically CTC, they're a consultant that does a lot of these state broadband projects, and they were trying to answer the question about fixed wireless versus fiber. But what they do, if you look at some of the tables on, I guess starting like page 43. They have great breakdowns by, as Dan mentioned, there's a lot of different, the densities and topologies and things like that. But they break out the construction, installation, design, electronics, and the fiber costs. So there's tons of great cost information there that I would encourage.
Oh, it's great resource.
Our audience to look at. There's a lot of good detail.
Jason, do you want to add it?
Yeah, I mean, I will add on to something that Dan hinted at, which is around labor and materials. And I think the labor aspect is one reason why we've been successful in some of the BEAD grant applications so far. We have an existing base of installation technicians and construction technicians that we can repurpose and move around to build new network. And so we are, compared to a smaller provider or a new upstart, a little bit less exposed to the very tight labor market that we have today. Certainly affected by it, like everyone, but having that ready pool of trained labor, is a big, leg up, if you will. And there's a lot of training there. There's a lot of safety related costs, and you name it. Apart from having enough, electronics and fiber in your supply chain.
So our time has flown by. We're nearly at the end. I'm going to ask kind of a two-part question for whoever wants to answer, and then each of you, let's give you a chance to offer any closing remarks in that too. First is about standards. We just haven't talked much about the international or even US-based standards. How do these bear on this issue, if at all? Dan, you may have some thoughts on this to chime in on. Jason, you haven't told us about the Comcast Innovation Fund. What does it do? How does it apply to this topic? And Gary, I guess it's a freebie for you, whatever you'd like to address here. And let's go in the same order we started with. Gary, Jason, what order do we start in? Gary, Jason, and Dan. Yes. Okay. You're on mute, Gary.
Yeah, got it. So I mean, we partner with the Broadband Forum as our technology partner. We have a technology group, but it's a deep dive, and they'll be at our conference in August. And so we really do spend some time looking at, standards and the evolution of technology and so forth. I think that's just kind of a given. But I guess I'll just close in saying that we really didn't get into it, but what we're really talking about here is the future of technology. And, we look at like a city like Chattanooga that is, was the first gigabit city in the world and the first 10 gig city, now the first 25 gig city. They also launched the world's first commercial quantum network. And the reason they can do that is their entire community is connected with fiber, which puts you in position to be able to have a quantum network. And so the quick takeaway, whether you're talking about metaverse or quantum networks or anything in the future, is if your community doesn't have fiber, you'll be left on the wrong side of the quantum divide or whatever the next thing divide is. And so we're excited that we're in this great opportunity to get fiber to every American and to make sure that everybody has digital equity and be able to lift the quality of life for everybody.
We'll definitely have to do a future special episode on quantum computing and quantum broadband. So thank you for bringing that up, Gary. Jason.
Sure. You asked about the Comcast Innovation Fund, and I posted the URL in the chat, innovationfund.comcast.com, to learn more. We are in our 11th year of operation, and we tend to focus on either research grants or open source development grants. So it may be, for example, an open source development grant to build an active queue manager for Linux or what have you, or it could be research into how does latency work and how can it be improved. So we try to do these small targeted grants that really help advance the state of network technology. We're not a big NSF type grant proposal sort of organization doing $2-3 million grants. Smaller scale, but very impactful things. So last few years, it's been around latency, DNS security, a whole range of things, BGP security, et cetera.
Thank you, Jason. And the last word to Dan.
You asked about standards, and I haven't been personally involved in standards in about 15 years. But from what I understand, it's business as usual. The standards committees have a lot of hard problems to solve, starting with the question of what do operators need, and then how do we get there? The 25 gig PON was an exception to that. Some people went into ITUT and said we should do a 25 gig PON, and they were shouted down. But 50 gig, 100 gig is really a bunch of engineers sitting in the room, many of them competitors, and hashing out what's the best way to do this. There's patents involved in this, of course, and there's bragging rights on the technology, and there's also who's ahead. But ultimately, it's a cooperative exercise, and it has been for decades.
Well, that will have to be the last word. We've really talked through a number of issues. It's been great to have all three of you. On behalf of Gary Bolton, who had to leave before this concluding, Jason Livingood, thank you, and Dan Grossman. I'm Drew Clark, and we'll see you next Wednesday. Take care, everybody, and bye.